Testing one, two, three.
Like a light, lighting up in the dark. You make it right, I forgot how to act. It's so classic. Every time you make me nervous and I lose my words. It's been a while since I forgot the most simple words. I feel calm when you're around, like nothing can break me. Yeah, yeah. Now I know why it never worked out before. High low, it would always turn out bad, so bad. But every time we start a fight, we always stop in time. We both know how to be gentle, never cross the line. I feel calm when you're around, like nothing can break me. Yeah, yeah.
Hi, Maddie. Can you see and hear me?
Yeah.
Okay. So let's go ahead and start. All right. So today we're going to go over how to solve linear equations with fractions and decimals. So it's just an extension of what we went over last time. But before we do that, we're going to have to go over the concept of least common denominator. Now, least common denominator is the same thing as least common multiple. By the way, did you have any problems with the homework or anything like that?
Um, no.
No? Okay. So, hold on. All right. So, least common denominator is the same thing as least common multiple. Least common denominator is just least common multiple for fractions. Okay. So, and it just means the smallest number that a set of numbers can divide into. Okay. So, given a problem like this one, where it's asking for the least common denominator between 3 and 5. One method you can use to find the least common denominator or multiple is to simply list out the multiples, right? So for 3, it's 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. For 5, it's 5, 10, 15, 20, 25, and so on. And what you would do is to find the least common denominator, you would find the smallest number that they both share, which is what? So what's
15.
15? Yeah, 15.
Are you supposed to be sharing your screen?
Oh, I'm not sharing my screen?
No?
Okay, sorry. Um okay, now I am, right?
Yeah.
Okay. All right, so as I've said before, the least common denominator is the same thing as the least common multiple, and it just means the smallest number that a set of numbers can divide into. So for this example, the LCD of 3 and 5, like I just said a minute ago, one way you can use to solve this is to simply list out the multiples of both numbers and then find the smallest number that they both share. In this case, it's 15. In fact, one of the things about the LCD is that if the numbers are prime like this, so prime, in other words, the factors of a prime number are what? 1 and the number itself. Well, both of these are prime. Okay, anytime you're asked for the LCM or the LCD of two prime numbers, it's just going to be the product of the two. So you could just, anytime you see the LCD of two prime numbers or three prime numbers or four, just take the product. In other words, multiply. But a commonly used method is going to be this listing out method where people list out the multiples. And that's another valid way to find the LCD. Um, However, as I explain here, for trying to find the LCD of larger numbers like 24 and 32, it's going to be too time consuming. So imagine trying to sit there and listing out the multiples of 24 and 32. It's not it's not a very fun experience. So an easier way is to use what's called prime factorization. Okay, prime factorization. So let's say I asked you to find the prime factorization of 12. Well, what we're doing is we're just breaking down a number into only its prime factors. Okay, so 12 is going to be made up of a bunch of prime numbers. at the end of this process. What we do is, or what I actually do is, I choose the smallest prime number that divides into 12. So one of them would be, you could start out with 2. Now, you don't have to do this. In fact, you could start out with other numbers that divide into 12, like 3 or 4, and you'll eventually end up with all the prime factors of that number. But I find it easier to kind of start off with the smallest prime number. In this case, 2. So 2 goes into 12 how many times?
6.
6. And then we look at this number and ask, what prime number goes into 6? Well, 2. And it goes in there 3 times. So you could break down this number, 12, into 2 times 2 times 2, or 2 squared times 3. Okay, notice these are all prime numbers. This is called a prime factor tree, okay, where we find out all the factors at the end, and these factors, these prime number factors of a, by the way, this is called a composite as a review. A number that's not a prime number is basically a composite number.
Yeah.
Okay, so at the very end of this process, you're going to be, this is called what's called the leaves of the prime factor tree. And they're all prime numbers. Okay, and so let's actually try out an example. Go ahead and find the prime factors of 27 using the prime factorization method, and let me know when you're done.
I'm done.
Okay, so in this case, what I would do is start off with 3. You don't have to. 3 goes into 27 9 times, and 9 is made up of 2 prime numbers, 3 and 3. Okay, so in this case, it would be 3 times 3 times 3. Is that what you got?
Yeah.
Okay, good. All right, so okay, so this is just asking for the prime factors of 12. We'll skip that. Okay, so let's try out this example. And it's asking for the LCD between 3 and 5. And okay, so we did that above. And again, these are prime numbers, so you could just take the product. So the least common denominator or multiple would be 15 of that. Okay, so to find the LCD, what you're going to do is take the prime factorizations of both numbers. By the way, this also works for more than 2 numbers. So it could be 3 or 4 or 5 numbers. But what you're going to do is take the prime factorization of both numbers, given 2 numbers, and then you're going to take the product of the 2. Now, usually that'll be the least common denominator, but there's an exception. And that's if you're asked to find the LCD of 2 numbers and the numbers share the same factor. In that case, what you're going to do is take the factor with the higher exponent and then get the product of those numbers. Okay, so I'll show you what I mean. So here we're asked to find the LCD of 6 and 9. Well, let's try it out. So 6, prime factorization is 2 and 3. So 2, we can write this as 2 times 3. And for 9, we can start out with 3 and 3. So 3 times 3 gives you 9. Both are prime numbers. So 3 times 3, or 3 squared. You want to write it in this exponential form because it's easier to see what's happening. So to find the LCD, what you're going to do is take the product between this and this. So we're going to take out a 2 because that's a factor. But notice how both prime factorizations contain 3 as a factor. Here we have 3 to the first power, and here we have 3 to the second power. So what I mean is, you want to take the one with the higher exponent, which is this one. Okay, the exponent on this is 2. So you're going to take out a 3 squared and then multiply. Take the product of these two. 2 times 9, 3 squared, okay? 2 times 9 is going to be 18. And that's going to be your LCD. Do you understand what I just did?
Yeah.
Yeah, so like I said, just one more time. You're going to take the product of their prime factors. But notice how they both share a 3. In that case, you're going to have to take the one factor with a higher exponent, which in this case is 3 squared. In cases, so what if both numbers had 3 to the first power as a factor, in other words, just 3, you would just take one of these out and take the product. Okay?
Okay.
But in cases where the exponent is higher, you want the one with the higher exponent. So go ahead and try this one, the LCD of 24 and 32, and let me know when you're done. Are you done?
I'm done now.
Okay. So we're going to take the prime factorization of 24 and 32, and we're going to take the product of those factors. So 24, 2 and 12, right? 2 times 12 gives you 24. 12 is going to be 2 and 6. 6 is going to be 2 and 3. So you can write this as 2 to the third times 3. Okay, that's the prime factorization of 24. Now let's go to 32. So that's going to be 2 and 16. 16 is going to be 2 and 8. 8 is going to be 2 and 4. And 4 is going to be 2 and 2. And we can write this as 2 to the 5th power. And then now you're going to combine these and take the product. So I'm going to take, which one has the higher exponent? Well, 2 to the 5th power. So you're going to take that. And then you're going to take the 3 out. And now we take the product. Well, 2 to the 5th power is what? It's 32. 32 times 3 is what? It's 3 times 30 plus 2. And that's going to be 90.
96.
Yeah, plus 6, which is 96. Therefore, 96 is your least common multiple or denominator. Good job. All right. So now that we know how to find the least common denominator, we're going to use that method to deal with equations with fractions, okay? When you're solving equations, you're going to run into situations where you run into fractions, and you don't want to deal with fractions when you're solving equations. It's not convenient. And the method to deal with it is to clear the fractions. In other words, get rid of the fractions by multiplying the whole equation by the LCD of the fractions. Okay? So in this case, here we have 1/2 x plus 3/4 equals 7/4. And what you're going to do is find the LCD, or the first thing you're going to do is find the LCD of 2 and 4, which are the denominators in this equation. Okay? 2 and 4. Well, 2 is already a prime number, so you don't have to do prime factorization for that one. And 4 is made up of 2 and 2. And what did I say when you were finding the LCD and they share a common factor?
You take the biggest exponent.
Yeah, so this is 2 to the first power, and this is 2 to the second power. So you're going to take that one. 2 to the second, so 2 to the second power is 4, so it's just going to be 4. And what you're going to do is basically multiply. You're going to multiply this whole equation by 4. Okay? And it should get rid of the fractions for us. So what we're doing is distributing the 4 to each term. Okay? 4 times 1/2 x. Well, that's going to be 2x. Okay? So that's 4 over 1 times 1/2. 2 goes into 4 twice. 2 times 1 is 2. We have 2 over 1, which is just 2. That's where that is coming from, the 2x. 4 times 3 over 4, the 4s are going to cancel. So what you're going to be left with is 3. 4 times 7 over 4, again, the 4s will cancel, and you're just going to be left with 7. So now look what we have here. We just have a regular equation that we're used to dealing with before. And that's what you want. And how would we solve this, Maddie?
We subtract 3 on both sides.
Yeah. We want the variable on the left side and all the constants on the other side. So we subtract 3 from both sides. And when we do that, we get 2x on the left side. And 7 minus 3 is 4. Divide both sides by 2. And we end up with x equals 4 over 2, which is what?
2.
2. Good. All right. Your turn. Here we have 3 over 2x plus 8 over 3 equals 10 over 3 plus 5 over 2x. And go ahead and try this and let me know when you're done. Okay, and then, so the key to this is going to be finding the LCD of 2 and 3. Okay?
Okay. I'm done.
Okay, so let's go ahead and work on this. Now, the LCD of 2 and 3 is going to be 6. Okay, I don't have to do prime factorization because both of these are prime numbers. So I'm going to multiply this whole thing by 6. And when I do that, so 2 goes into 6 3 times. 3 times 3 is 9. So we're going to end up with 9x. 3 goes into 6 twice. 2 times 8 is 16. 3 goes into 6 twice. 2 times 10 is 20. 2 goes into 6 3 times. 3 times 5 is 15. So we have 15x. And now we have our ordinary linear equation that we can solve easily. So I'm going to subtract 15x from both sides. To get x on the left side, I'm going to subtract subtract 16 from both sides to move it to the right side. And when I do that, I end up with negative 6x equals 2 minus 16. 20 minus 16 is 4. Divide both sides by negative 6. So I end up with x equals negative 4 over 6. They share a greatest common factor of 2. So I'm going to divide both the numerator and the denominator by 2. And what you get is negative 2 over 3. Is this what you got?
Yeah.
Yeah? Okay. Good job. All right. Let's try one more. Actually, how many of these are? Okay, we still have equations with decimals to go. So let's try one more. This is negative 10 over 3 times the quantity of negative 7 over 2x plus 1 equals 95 over 3. And notice how I've noted here, it says resist the urge to just go in and use the techniques you've learned. In other words, learn to look at the problem and simplify wherever things can be simplified if possible. Okay?
Okay.
All right. And by the way, if you have questions to ask me about what we're learning, don't be afraid to just ask me right away, okay?
Okay.
All right.
I'm done.
Okay. So, as I've noted here, you want to simplify if things can be simplified before you start using the techniques. You want to simplify by distributing this negative 10 over 3 first. Okay? So, what happens when we do that? So, this is negative 10 over 3 times negative 7 over 2. We can cross simplify. So we end up, 2 goes into 10 5 times. Negative 5 times negative 7 is positive 35.
Oh yeah, positive 35.
Yeah. And then 3 times 1 is just 3. So we have 35 over 3x. And then 10 over 3 times 1 is just 10 over 3.
Yeah.
Negative. Oh. Ignore that. So 10 over 3 equals 95 over 3. And notice now, you actually don't need to clear the fraction because they all have the same denominator. So you can just, so you can just solve this right away. So what should our next step be?
Add 10 over 3 by both sides.
Yeah. So you're going to add 10 over 3 to both sides. That's going to cancel. And so on the left side, we have 35 over 3. X equals 95. What's 95 over 3 plus 10 over 3?
105.
105 over 3.
Oh, yeah.
Yeah. Okay, so in this case, so the 35 over 3 is multiplying x. The way I would get rid of that is to multiply both sides by the reciprocal of 35 over 3. What's the reciprocal of 35 over 3?
3 over 35?
Mm-hmm. So I'm going to multiply both sides by the reciprocal. That's going to get rid of that, so we're just left with x on the left side. And on the right side, we have 105 over 3 times 3 over 35. 3's are going to cancel. Let's see. 105 and 35. Does 35 times 3? Yeah. So we have 105 over 35. Okay, if you multiply it out, and that 105 is divided by 35 is going to be 3. So x is going to equal 3. Okay?
Yeah.
Is that what you got?
Yeah.
Okay, good. All right, let's move on. Here we have equations with decimals. So we've gone over least common denominator, how to find the least common denominator. We used the method of prime factorization to find the least common denominator, and we used the least common denominator to clear fractions when you run into equations with fractions. And now we're dealing with decimals because we don't like decimals either, okay? Sometimes decimals are nice to deal with, but I'd rather not work with decimals. So the technique to clear decimals is by multiplying. We're going to multiply the whole equation by 10 to the nth power. Okay? 10 to the nth power, where n is the largest number of decimal places in the whole equation. So I'll show you what I mean. But before we do that, let's work with some decimals a little bit more. So in this example, it says, what number do we need to multiply the number below to clear the decimal? So we have 0.53. What number? So here I said you have to multiply the whole equation by 10 to the nth power, where n is the number of decimal places you have. So what number will we need to multiply this by to move the decimal point 2 places to the right?
100.
Yeah, because how many numbers do we have behind the decimal? We have 2, right? 1,
Yeah.
2. So you're going to multiply that by 10 to the second power. 10 to the second power is 100. And that's going to automatically clear the decimals for us. And this is going to turn into a 53. Okay?
Yeah.
If you were to multiply 0.53 instead by 10 to the third power, which is 1,000, you would just move the decimal places 3 times. Okay? So we have 0.53, and it would go, the decimal place would move to the right 3 times. 1, 2, 3. And then we're going to be left with 530. Okay?
Yeah.
All right, so another one. What number do we need to multiply both numbers below to clear the decimals at the same time?
3.
10 to the third power.
Yeah.
In other words, 1,000. That would make, like I just went over before, that would make 0.53 530, and then that would make this 535. Okay, both numbers, the decimal places would go to the right 3 times. 1, 2, 3. Okay?
Yeah.
Okay, we got that. All right. So let's try an example of an equation with decimals. And it says solve for x. And you want your, usually, I don't know if it's required. Some teachers, I think, don't care for it, but usually they're going to want your answer in decimal form. Okay? So here we have negative 16.8 minus 5.5x equals 8 plus 6.9x. What number should I multiply this whole thing by to get rid of these decimals?
10.
Yeah, just 10. 10 to the first power. Okay? So you're going to multiply this whole thing by 10. And you don't even, so here I'm distributing this 10 across this equation, but you don't even need to actually sit there and multiply. Just move the decimal place. Since we're multiplying by 10, all you have to do is move the decimal place one place to the right for each term. Okay, so when we do that, we get negative 168. We get negative 55x equals 10 times 8 is 80. And then 10 times 6.9, that's going to be 69x. And now we can just solve like how we're used to solving it. So what would I do here now?
Add 55x on both sides. And wait, no. Add 168 on both sides. And then subtract 69x on both sides.
Yeah, good. Okay, so those are going to cancel. Those are going to cancel. We have negative 55 and negative 69. That's going to be what? So 9 plus 5 is 14. 1 plus 5 plus 6 is 12. Negative equals 80 plus 168. So that's going to be 8, 14. 1 plus 1 is 2. Okay. I forgot the x. Yeah. And now we divide both sides by 124 to isolate x. And when we do that, we get x equals,
-2.
yeah, so
Oh,
124 actually goes into 248 2 times. So good. So your answer is going to be -2. Good job. And as a decimal, this would be just 2.0.
okay.
So there's going to be situations where you get an answer, like a fraction, and usually they're going to want you to convert that fraction into decimal form. And you would do that by actually doing the division, right? So if you have something like 3 over 2, as a decimal, that's going to be what? 1.5. And so you would want to write it that way.
Okay.
Okay. It's not always required, but I think some teachers want you to do that. All right, so this example is for you, and let me know when you're done.
Okay. I'm done.
Okay. So the first thing we're going to do is simplify by distributing the negative. There's same situation on both sides. And that's just going to reverse the signs of what's inside. So we get positive 2x and negative 0.2 equals positive x, positive 9, plus 1.7. And we can actually simplify this side. That's going to be what? X plus 10.7. And on the left, we have 2x minus 0.2. And now we can multiply both sides by 10, since there's only one decimal places in the equation. So we're going to multiply by 10 to get rid of the decimals. And when we do that, we get 20x minus 2 equals 10x plus 10 times 10.7. What is that? So 10 times 10 is 100. 10 times 0.7 is
107.
Yeah, 107. So we have that going on. And then now we can just solve. So we're going to subtract 10 from both sides. We're going to add 2 to both sides. That cancels. That cancels. 20x minus 10x is 10x equals 107 plus 2 is 109. We're going to divide both sides by 10. And so we have x equals 109 over 10. I don't think they have any common factors, but we want it in we want it in decimal form. So
10.9.
Oh, you're right. All we have to do is move the decimal place one spot to the left. Okay, good job. All right, is that it? It looks like that's it. Do you have any questions over what we went over?
No.
No? Okay. So the homework is going to be this one right here. Algebra 1, solving linear equations in one variable, part 2. Due tomorrow, okay?
Okay.
All right. Good job.
Bye.
All right, bye-bye.